Okay, this is just a quick demonstration of what a precipitation reaction really is. And so what we have here is in this test tube, I have a clear liquid, okay? It's got some ions dissolved in it, and right now they're perfectly happy to be in solution, the way we've talked about. It's a strong electrolyte dissolved in a solution. The ions are completely dispersed in there at whatever concentration we prepared. This is another test tube, also with a clear liquid in it. Same situation. I have dissolved a particular electrolyte in this solution, and the ions are separate and perfectly happy to be in solution. But now watch what happens when I pour some of this solution into this test tube. Okay, so you can see that it's now filled with a cloudy, milky substance. And what that is it's a very, very fine particulate. Okay, I'll set this down, and you'll see that the particles, the powder basically, will start to settle out of the solution. I don't know how good the quality on the camera is. Let me see if I can improve the lighting here. So that's a little bit better, maybe, with the lighting, although the camera's adjusting. So I'm trying to get it so that you can see that there is really kind of a powder in there. You can kind of start to be able to see through it, see something on the other side as that powder settles out of the solution. Okay? What this was that this test tube here has calcium chloride in it. Okay? That's just a way of getting calcium ions dissolved in this solution, because calcium chloride is a strong electrolyte. This tube had sodium, this tube, the tube that I poured it into, had sodium carbonate in it. Okay? Sodium carbonate is another strong electrolyte, dissolves perfectly in water. The problem is that when the calcium ions in this solution got mixed in, they encountered the carbonate ions that were dissolved in this solution, and those two guys together are no longer soluble. Okay? They are not a strong electrolyte. Calcium carbonate is a weak electrolyte, and so what happens is when those calcium ions find the carbonate ions in this solution, they say, oh no, we don't want to be in solution anymore. We need to fall out as a solid precipitate. And that's what's very slowly filtering down. If you look closely, I don't know how well it shows up on the screen, but there is a layer developing in the middle where you can see that it's more transparent at the top and less transparent at the bottom. Okay, let's let that sit a little longer, and we'll be able to do it while we do another one. So this tube has calcium oxalate in it. Sorry, this tube has sodium oxalate in it. Oxalate is another ion, we'll write the formula in just a minute, that it can be dissolved as a strong electrolyte when it's paired with a sodium ion. However, when the calcium hits it, remember this is calcium chloride, so when the calcium ions hit it, again, we see that milky white precipitate. Almost instantaneously, you see that the calcium finds the oxalate ions dissolved in that solution, and they're like, whoops, we're not a strong electrolyte, we're a weak electrolyte, we're going to fall out of solution as a precipitate, as a solid precipitate. Okay? And so the way that we would write this is that we would say that calcium chloride solution plus the first one would be sodium carbonate. Those two solutions, when they mix, what happens is we call this a double displacement reaction. The calcium cation switches place with the sodium cation. So that means on the other side, we're going to have calcium paired with carbonate, and that was the thing that's no longer a strong electrolyte. That doesn't dissolve completely in water, and so it comes out as a solid. This is our precipitate, which we abbreviate in chemistry as PPT. The other ions, in this case, stay in solution. So we would end up with sodium chloride. So just table salt, which of course is a strong electrolyte. So that's going to stay in solution as an aqueous product of this reaction. Anything wrong with this? If you look carefully, you should notice that, well, I've got 2 chlorides and 2 sodiums, so I need to put a 2 here. Okay? And we'll explore some other ways to write this in a future lecture. Just to complete this, we can do it for the oxalate. So if we look at sodium oxalate, okay, so it's an ion we haven't talked about. Sodium oxalate is a strong electrolyte. So is calcium chloride. But when we mix those together, and those calcium 2+ ions find the oxalate 2- ions, they form that white precipitate that we saw in the second reaction. Okay, that one's not really falling down much, but you can see that the first one is really starting to settle out now. I'll use a piece of paper to make that a little bit clearer. It's really starting to settle out now, and you can see the powder slowly settling down to the bottom. So it's, in case you didn't believe me, that it was a solid precipitate. And then here, the other component is again going to be the sodium chloride, and we're going to need 2 of them to balance the equation. Okay, so that's how precipitation reactions work.